82 facts about our galaxy to fall asleep to. Close your eyes and imagine floating in the vastness of space, looking down upon a magnificent spiral of light stretching across the darkness. This is our home, the Milky Way galaxy, and tonight, we're going to explore its wonders together as you drift into peaceful sleep. Fact 1. Our galaxy is ancient beyond imagining. When you look up at the night sky and see that faint band of light stretching from horizon to horizon, you're seeing a structure that began forming approximately 13.6 billion years ago, not long after the universe itself was born. Think about that for a moment. The Milky Way has been spinning through space for almost as long as time itself has existed. Fact 2. And what a size it is. If you could somehow travel at the speed of light, the fastest speed possible in our universe, it would take you about 100,000 years just to cross from one edge of the galaxy to the other. That's right, 100,000 years at 186,000 miles per second. The sheer scale is almost impossible to comprehend, and yet here we are, nestled safely within it. Fact 3. Within this vast expanse, our galaxy is home to somewhere between 100 billion and 400 billion stars. Imagine trying to count them, one per second. Even at the lower estimate, it would take you over 3,000 years, counting day and night without stopping. Each of those stars is a sun, many with their own families of planets, their own stories unfolding across the cosmic stage. Fact 4. But stars aren't the only inhabitants of our galactic home. The Milky Way also contains an estimated 100 billion planets, at least. Some are gas giants larger than Jupiter, others are rocky worlds like Earth, and many are types we've never even seen up close. Somewhere out there in that sea of worlds, orbiting distant suns, there may be others looking up at their night sky, wondering if they're alone. Fact 5. Our galaxy isn't just stars and planets floating in empty space. Between the stars lies something called the interstellar medium, a thin soup of gas and dust that fills the space between solar systems. About 99% of this material is gas, mostly hydrogen and helium, the simplest elements in the universe. The remaining 1% is cosmic dust, tiny grains no bigger than particles of smoke, made of heavier elements like carbon, silicon, and iron. This dust may seem insignificant, but it's from this humble material that new stars, planets, and eventually life itself can form. Fact 6. From above, if we could see our galaxy from outside, the Milky Way would reveal itself as a barred spiral galaxy. Picture a cosmic pinwheel with graceful arms spiraling outward from a bright central bar. We have 4 major spiral arms, each named by astronomers: the Perseus arm, the Sagittarius arm, the Scutum Centaurus arm, and the outer arm. These arms aren't solid structures but rather regions where stars, gas, and dust concentrate more densely, like traffic jams on a cosmic highway, slowly rotating around the galactic center. Fact 7. And where do we fit into this grand spiral? Our solar system, with Earth and all the familiar planets, resides in a small partial arm called the Orion Spur, or sometimes the Orion Bridge. We're located about 26,000 light-years from the galactic center, roughly halfway out toward the edge. We're in the suburbs of the galaxy, you might say, away from the crowded downtown but not quite in the rural outskirts. Fact 8. The entire galaxy is slowly, majestically rotating. At our location, the solar system orbits the galactic center at approximately 515,000 miles per hour. That sounds incredibly fast, and it is, but the galaxy is so vast that it takes our solar system about 225 to 250 million years to complete just one orbit around the center. The last time we were in this same position in our galactic orbit, dinosaurs were just beginning to dominate the Earth. Since our planet formed, we've only made about 20 trips around the galaxy. Fact 9. As you settle deeper into rest, let me share one more wonderful detail about our cosmic journey. One complete orbit of our solar system around the galactic center is sometimes called a galactic year, or cosmic year. In the 4.6 billion years that Earth has existed, we've completed only about 20 of these galactic years. Imagine, the entire span of human history, from the first civilizations to today, represents just a tiny fraction of one galactic year. As you settle deeper into rest, imagine yourself on that slow, eternal journey, carried along with our sun and all its planets, traveling through space on an orbit that has repeated countless times before and will continue long after we're gone. You're part of something ancient, vast, and beautiful. You're a child of the Milky Way, made of the same stardust that fills its spiral arms. Rest now, knowing that you're exactly where you're meant to be, in this moment, on this world, in this galaxy. As you breathe slowly and deeply, let's journey toward the heart of our galaxy, where something extraordinary awaits in the darkness. Fact 10. At the very center of the Milky Way, hidden behind vast clouds of dust and gas, lies a supermassive black hole. We call it Sagittarius A*, and it's difficult to truly grasp its nature. This black hole contains the mass of approximately 4 million of our suns, all compressed into a region smaller than the orbit of Mercury. It sits there, ancient and patient, the gravitational anchor around which our entire galaxy slowly wheels. Don't worry though, we're perfectly safe here in our distant corner of the galaxy. The black hole's influence is powerful at the center, but out here, 26,000 light-years away, it's just one part of the gravitational balance that keeps everything in harmony. Fact 11. Surrounding this dark heart is something beautiful and bright. The central bulge of our galaxy is a roughly spherical region packed densely with stars, most of them older, reddish stars that have been shining for billions of years. If you could stand on a planet near the galactic center, your night sky would be breathtaking beyond words. Thousands of stars would be visible to the naked eye, so many and so bright that night would never truly be dark. The stars would cast shadows, and you could read by their combined light. Fact 12. The Milky Way isn't traveling through space alone. It's part of a small cosmic family called the Local Group, which contains more than 50 galaxies bound together by gravity. Most of these are small dwarf galaxies, but 3 are large spirals: our Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. We're all moving through space together, a small cluster in the vast universe, neighbors on the grandest scale imaginable. Fact 13. And speaking of neighbors, the Andromeda Galaxy is on a collision course with us. Don't let this disturb your rest, though. Andromeda is currently about 2.5 million light-years away, and it's approaching at roughly 68 miles per second. That sounds fast, but the universe is patient. The two galaxies won't begin to collide for another 4.5 billion years. And even when they do meet, the vast distances between individual stars mean that actual collisions will be rare. Instead, the two galaxies will dance around each other, their spiral arms distorting and eventually merging into a new, larger elliptical galaxy. By then, our Sun will already be nearing the end of its life, and Earth, if it still exists, will have been transformed beyond recognition. Fact 14. Let's think about the age of the stars around us. The Milky Way contains stars of vastly different ages, like a cosmic family with many generations living together. The oldest stars in our galaxy are found in globular clusters, dense spherical collections of stars that orbit above and below the galactic disk. Some of these ancient stars are nearly as old as the universe itself, born over 13 billion years ago when the galaxy was just forming. They're made of almost pure hydrogen and helium because they were born before many heavier elements existed. Fact 15. In contrast, our Sun is a relative youngster, only about 4.6 billion years old, middle-aged in stellar terms. It's what astronomers call a population 1 star, meaning it contains heavier elements created by previous generations of stars that lived, died, and scattered their enriched material back into space. Every atom of carbon in your body, every atom of oxygen you breathe, every atom of iron in your blood, was created in the heart of a star that exploded billions of years ago, somewhere in our galaxy. You are literally made of stardust, the processed material of ancient suns. Fact 16. The disk of our galaxy, where most of the stars reside including our Sun, is remarkably thin relative to its width. If you were to create a scale model of the Milky Way where the galaxy was the size of the United States, the disk would only be about as thick as a coin. We live in a vast, flat spiral, and this shape comes from the galaxy's rotation. Just as a pizza maker spins dough to flatten it, the rotation of our galaxy has flattened most of its material into a thin disk over billions of years. Fact 17. But not everything is confined to this disk. Our galaxy is surrounded by a spherical halo that extends far beyond the visible spiral arms. This halo contains those ancient globular clusters we mentioned, along with streams of stars and, most mysteriously, vast amounts of something called dark matter. This invisible substance doesn't emit light and can't be seen directly, but we know it's there because of its gravitational effects. In fact, astronomers believe that about 90% of the Milky Way's total mass is dark matter. We live in a galaxy where most of the mass is something we can't see, a humbling reminder of how much we still have to learn about the universe. As you sink deeper into sleep, imagine the Milky Way as it truly is, a vast, ancient, spinning island of light in space, held together by visible and invisible forces, containing billions of suns and worlds, with a dark heart at its center and a halo of mystery surrounding it all. And somewhere in its spiral arms, on a small blue planet orbiting an ordinary yellow star, you rest peacefully, a conscious piece of the universe contemplating itself. Let the immensity of it all wash over you like a gentle wave, and know that you are home. As your breathing slows and deepens, let's explore the life within our galaxy, the cycles of birth and death that have continued for billions of years. Fact 18. Throughout the Milky Way, new stars are being born even as you rest. Our galaxy creates approximately 1.5 to 3 new stars every single year, though some estimates suggest it could be as high as 7 stars per year. These stellar nurseries are found in giant molecular clouds, vast regions of cold gas and dust where gravity slowly pulls material together. The process is slow and patient, taking millions of years, but it's happening right now in hundreds of places across the galaxy. Each new star is a continuation of the cycle, a fresh light igniting in the cosmic darkness. Fact 19. One of the most beautiful stellar nurseries visible from Earth is the Orion Nebula, a glowing cloud of gas located about 1,344 light-years away from us. On a clear night, you can see it with the naked eye as a fuzzy patch in Orion's sword, hanging below the 3 bright stars of his belt. Within that soft glow, hundreds of young stars are forming, some only a few 100,000 years old, mere infants in cosmic terms. It's a reminder that the galaxy is not static, but alive with constant change and renewal. Fact 20. The Milky Way also has a stellar graveyard, though it's not as dark as that name might suggest. When massive stars reach the end of their lives, they don't fade quietly. Instead, they explode in spectacular supernovae, briefly outshining entire galaxies before fading away. These explosions are rare, but powerful. In our galaxy, a supernova occurs approximately once every 50 years on average, though many are hidden from our view by dust and distance. The last supernova visible to the naked eye in the Milky Way was observed in 1604 by Johannes Kepler, over 400 years ago. We're actually overdue for another one. Fact 21. When these massive stars explode, they leave behind remnants that tell stories of their violent deaths. Sometimes they leave behind neutron stars, incredibly dense objects where a mass greater than our Sun is compressed into a sphere only about 12 miles across. A teaspoon of neutron star material would weigh about 6 billion tons on Earth. Other times, if the star was massive enough, the core collapses completely into a black hole, joining the countless others scattered throughout the galaxy. Fact 22. The Milky Way is filled with these stellar remnants. Astronomers estimate there are approximately 100 million black holes scattered throughout our galaxy, most of them stellar mass black holes created from the deaths of massive stars. These aren't the supermassive black hole at the center, but smaller ones, typically ranging from a few to dozens of times the mass of our Sun. They drift through space, invisible, detectable only when they interact with nearby matter or companion stars. Fact 23. Our galaxy is not only creating and destroying stars, but also creating the very elements that make up everything around us. The Milky Way is a cosmic forge, and every generation of stars adds to the chemical complexity of the galaxy. The universe began with only hydrogen, helium, and traces of lithium created in the Big Bang. Every other element, from the carbon in your cells to the gold in jewelry, was created inside stars or in supernova explosions. Over billions of years, the Milky Way has been enriched with heavier elements, what astronomers call metals, even though that includes elements like oxygen and carbon. Our solar system, born 4.6 billion years ago, formed from gas that had already been enriched by multiple generations of stars. Fact 24. The spiral arms of our galaxy, those beautiful sweeping curves we mentioned earlier, aren't permanent structures. They're actually density waves, regions where stars, gas, and dust temporarily bunch together as they orbit the galactic center. Think of them like traffic jams on a highway. The cars in a traffic jam are constantly changing, moving through the congested area and then speeding up again, but the traffic jam itself can persist in the same location. In the same way, stars and gas clouds move through the spiral arms, which rotate at a different speed than the stars themselves. This creates the appearance of permanent arms, even though the material within them is constantly flowing. Fact 25. Within these spiral arms, the density of material is higher, and this triggers star formation. When gas clouds enter a spiral arm, they're compressed by the increased density, and this compression can cause them to collapse and form new stars. This is why the spiral arms appear bright and blue in images of spiral galaxies. They're lit up by young, hot, massive stars that have recently formed there. These massive blue stars don't live long, only a few million years, so they never drift far from where they were born before they die. The spiral arms are thus marked by the short, brilliant lives of these stellar giants. As you drift further into restful sleep, imagine the galaxy as a living entity, breathing in and out, creating and destroying, enriching itself generation by generation. The light you see from distant stars left them years, decades, or centuries ago. When you look at the night sky, you're seeing the galaxy's past, a shimmering message written in ancient starlight. And in that light, carried across vast distances and immense spans of time, is the story of where we came from, and the promise of countless wonders still waiting to be discovered. Rest in the knowledge that you are part of this grand cycle, made of atoms forged in stellar furnaces, living in a galaxy that continues to evolve and grow. Gentle pause before continuing to next section. Let your mind wander now through the neighborhoods of our galaxy, through regions both familiar and strange, as we discover more about the stellar communities that surround us. Fact 26. The stars in our galaxy aren't distributed evenly. They're organized into what astronomers call stellar populations, and these populations tell us about the galaxy's history. The oldest stars, which we call population 2 stars, are found primarily in the galactic halo and in globular clusters. They're metal poor, meaning they contain very few elements heavier than hydrogen and helium. The younger stars, population 1 stars like our Sun, are found mainly in the galactic disk and contain more heavy elements. There's even a theoretical population 3, the very first stars that formed in the universe, made of nothing but primordial hydrogen and helium. None have been observed yet, but somewhere out there, remnants of these first lights may still exist. Fact 27. Our Sun has siblings scattered throughout the galaxy. About 4.6 billion years ago, our Sun was born in a stellar nursery alongside perhaps thousands of other stars, all formed from the same giant molecular cloud. Over billions of years, these sibling stars have drifted apart, dispersed by the galaxy's gravitational forces and their own orbital motions. They're now scattered across the Milky Way, and astronomers are actively searching for them. A few candidates have been identified, stars with similar ages and chemical compositions to our Sun, possible brothers and sisters separated by time and distance, each perhaps with their own families of planets. Fact 28. The Milky Way is warped. Yes, our galaxy isn't perfectly flat. If you could view it edge-on from a great distance, you'd see that the outer regions of the galactic disk are twisted and warped, like the brim of a hat that's been sat on. This warping is thought to be caused by gravitational interactions with our satellite galaxies, particularly the Large and Small Magellanic Clouds, which are slowly orbiting us. These two dwarf galaxies are gravitationally tugging on our galaxy's outer edges, creating ripples and distortions that travel through the disk like waves on a pond. Fact 29. Speaking of the Magellanic Clouds, these two irregular dwarf galaxies are among our closest galactic neighbors, visible to the naked eye from the southern hemisphere as fuzzy patches of light. The Large Magellanic Cloud is about 160,000 light-years away, and the Small Magellanic Cloud is about 200,000 light-years distant. They're in orbit around the Milky Way, though that orbit is so vast it takes them about 1.5 billion years to complete. But these galaxies won't be our companions forever. Eventually, in a few billion years, they'll likely be consumed by the Milky Way, their stars added to our galaxy's collection in a slow-motion cosmic merger. Fact 30. The Milky Way has a thick disk in addition to the thin disk we mentioned earlier. While the thin disk, where our Sun resides, is only about 1,000 light-years thick and contains younger stars and lots of gas and dust, the thick disk extends about 3,000 light-years above and below the galactic plane. The thick disk contains older stars, typically 10 billion years old or more, with different orbital characteristics than the thin disk stars. They move in more random, elliptical orbits rather than the orderly circular paths of thin disk stars. This thick disk might be the remnant of ancient galaxy collisions, or it might represent an earlier phase of the Milky Way's formation. Fact 31. Our galaxy rotates in a complex way that puzzled astronomers for decades. If the galaxy rotated like a solid object, like a spinning DVD, stars farther from the center would move faster, just as a point on the outer edge of a spinning disk travels faster than a point near the center. But that's not what we observe. Instead, the rotation curve of the Milky Way is nearly flat, meaning stars in the outer regions orbit at roughly the same speed as those closer in. This was one of the first clues that led astronomers to propose the existence of dark matter. There must be additional invisible mass extending far beyond the visible disk, providing the extra gravity needed to keep those outer stars moving so quickly. Fact 32. The Milky Way contains numerous stellar streams, long rivers of stars stretching across the sky. These streams are the torn-apart remains of globular clusters and small dwarf galaxies that ventured too close to our galaxy and were ripped apart by tidal forces. As these objects orbit through the Milky Way, our galaxy's gravity pulls them like taffy, stretching them into long, thin streams that wind around the galaxy. The Sagittarius stream is one of the most prominent, a ribbon of stars from the Sagittarius dwarf elliptical galaxy that's currently being cannibalized by the Milky Way. These streams are fossils of past interactions, written across the sky in stars. Fact 33. Within our galaxy, there are regions called HII regions, named after ionized hydrogen. These are vast clouds of glowing gas, illuminated by the intense ultraviolet light from young, hot stars forming within them. The radiation from these newborn stars is so energetic that it strips electrons from hydrogen atoms in the surrounding gas, causing it to glow with a characteristic reddish-pink color. Some of the most famous HII regions have beautiful names: the Eagle Nebula, the Lagoon Nebula, the Trifid Nebula. Each is a vast stellar maternity ward, where gravity and light sculpt gas and dust into intricate shapes, and where the next generation of stars is taking its first breath. As you rest more deeply now, imagine the Milky Way not as a static photograph, but as a dynamic, living ecosystem. Stars are born and die, galaxies merge and are torn apart, dark matter weaves its invisible web, and through it all, the great spiral continues its ancient rotation. You're floating through this cosmic ocean, safe and serene, part of a story that began billions of years ago and will continue for billions more. Let the gentle rhythm of the galaxy's rotation lull you deeper into peaceful sleep. As you sink deeper into tranquility, let's explore the remarkable objects and phenomena that make our galaxy so extraordinary, the exotic wonders that await discovery in the dark spaces between the stars. Fact 34. The Milky Way contains objects called pulsars, which are rapidly rotating neutron stars that emit beams of radiation from their magnetic poles. As these beams sweep across space like cosmic lighthouses, we detect them as regular pulses of radio waves, some flashing dozens or even hundreds of times per second. The first pulsar was discovered in 1967, and its regular pulses were so precise that astronomers briefly wondered if they had detected signals from an alien civilization. They even nicknamed it LGM-1, for Little Green Men. Of course, we now know these are natural phenomena, but their clockwork precision is no less remarkable. Some pulsars keep time more accurately than the best atomic clocks on Earth. Fact 35. Our galaxy is home to binary star systems, where two stars orbit around their common center of mass, locked in a gravitational dance. In fact, binary systems are remarkably common. More than half of all stars in the Milky Way are part of binary or multiple star systems. Some of these pairs are so close they share material, with gas streaming from one star to its companion. Others are separated by vast distances, taking thousands of years to complete a single orbit. If Earth orbited in a binary system, we would have two suns in our sky, creating double shadows and spectacular sunrises where one sun rises as the other sets. Fact 36. There are mysterious objects in our galaxy called magnetars, neutron stars with magnetic fields 1 trillion times stronger than Earth's magnetic field. These are the most magnetic objects known in the universe. A magnetar's magnetic field is so intense that it would be lethal to any life form that came within 600 miles of it, and it would warp the very atoms in your body. Occasionally, magnetars experience starquakes, sudden shifts in their crust that release enormous bursts of X-rays and gamma rays. These outbursts can be detected across the galaxy, brief but incredibly powerful flashes from these exotic remnants of stellar death. Fact 37. The Milky Way contains vast structures called superbubbles, enormous cavities in the interstellar medium carved out by multiple supernova explosions. When massive stars form in clusters, they live fast and die young, and many of them explode as supernovae within a relatively short time. These combined explosions can blow enormous bubbles in the surrounding gas, sometimes hundreds of light-years across. The local bubble, which contains our solar system, is one such cavity, about 300 light-years wide. We're living inside a bubble created by ancient supernova explosions that occurred millions of years ago, now filled with thin, hot gas through which we peacefully drift. Fact 38. Brown dwarfs wander through our galaxy in countless numbers. These are objects that formed like stars but never gained enough mass to sustain hydrogen fusion in their cores. They're sometimes called failed stars, though that seems unkind. They're simply objects that exist in the twilight zone between the largest planets and the smallest stars, typically with masses between 13 and 80 times that of Jupiter. Brown dwarfs glow faintly with the heat left over from their formation, slowly cooling over billions of years. They're difficult to detect because they emit mostly infrared light, but modern surveys suggest there may be billions of them throughout the Milky Way, dim nomads drifting through the darkness. Fact 39. The Milky Way has a feature called the Fermi bubbles, two enormous structures extending 25,000 light-years above and below the galactic center. These bubbles were discovered in 2010 by the Fermi Gamma-ray Space Telescope, and they glow with high-energy gamma rays. Scientists believe they were created by a massive burst of energy from the supermassive black hole at our galaxy's center, perhaps from a period of intense feeding activity millions of years ago. These bubbles are evidence that Sagittarius A** wasn't always as quiet as it is today. In the past, our galaxy's heart was far more active and violent. Fact 40. Hypervelocity stars race through our galaxy at incredible speeds, fast enough to escape the Milky Way's gravitational pull entirely. These stellar speed demons are traveling at more than 1,000 kilometers per second, having been flung outward by gravitational interactions with the supermassive black hole at the galactic center, or perhaps ejected from binary systems when their companions exploded as supernovae. These stars are literally being shot out of our galaxy, destined to wander the void between galaxies forever. Hundreds of hypervelocity stars have been identified, each one telling a story of a dramatic encounter that sent it flying into the cosmic deep. Fact 41. Within the Milky Way, there are regions of space called molecular clouds where the temperature drops to just 10 or 20 degrees above absolute zero, making them among the coldest places in the universe. These frigid regions are where stars are born, where gravity slowly pulls together wisps of gas and dust over millions of years. The cold is essential. It allows the gas to collapse under its own weight without being disrupted by heat and pressure. In these cosmic deep freezers, simple molecules can form on the surfaces of dust grains, water ice, carbon monoxide, methanol, and even more complex organic compounds. The building blocks of life itself may be forged in these frozen stellar nurseries. As your body grows heavier and your breathing slows, imagine yourself drifting past these wonders. Pulsars spinning their beams through darkness, binary stars waltzing together, magnetars with their impossible magnetic fields, and stars racing toward the edge of the galaxy and beyond. Each phenomenon is real, verified by observation and measurement, yet each seems to belong more to dreams than to reality. The universe is stranger and more wonderful than we ever imagined, and you are floating peacefully through it all. Rest now in the certainty that the cosmos is vast enough to contain infinite wonders, and gentle enough to cradle you in its embrace. As you drift deeper into the realm of dreams, let's turn our attention to the light itself, to the ways we perceive our galaxy and the hidden structures that only reveal themselves to patient observers. Fact 42. When you look at the Milky Way stretched across a dark night sky, you're actually looking into the disk of our galaxy from inside it. That band of light is the combined glow of billions of stars too distant to see individually, all blending together into a river of soft luminescence. But here's something remarkable: you can only see about 0.000003% of the stars in our galaxy with your naked eye. On the very best night, from the darkest location on Earth, you might see about 4,500 stars. The rest, hundreds of billions of them, remain invisible to your eyes alone, their light too faint or too distant, a reminder of how much of the universe exists beyond our direct perception. Fact 43. The Milky Way appears different depending on where you are on Earth. From the northern hemisphere, the galactic center is low on the horizon during summer months, and the view is somewhat obscured. But from the southern hemisphere, particularly from places like Chile, Australia, or South Africa, the galactic center passes nearly overhead, revealing the brightest and most spectacular portion of the Milky Way. Ancient cultures in the southern hemisphere developed rich mythologies around these dark dust lanes and bright star clouds, seeing in them everything from cosmic rivers to the paths of departed spirits. Fact 44. Our galaxy contains something called the zone of avoidance, a region where our view of the universe beyond the Milky Way is blocked by the thick dust and gas in our own galaxy's disk. When we look toward the galactic plane, particularly toward the galactic center, so much material lies between us and distant galaxies that we simply can't see through it with optical telescopes. About 10% of the sky is hidden in this zone. It's like trying to see distant mountains through a thick fog. The mountains are there, but the fog obscures them completely. Radio and infrared observations can partially penetrate this zone, revealing some of what lies beyond. Fact 45. The Milky Way has something astronomers call the galactic habitable zone, a region of the galaxy where conditions might be most favorable for life. This zone is thought to be a ring-shaped region, far enough from the galactic center to avoid frequent supernovae, gamma-ray bursts, and intense radiation, but close enough that stars have sufficient heavy elements to form rocky planets. Too close to the center, and the environment becomes too hostile. Too far out, and stars may lack the elements needed for planet formation and life chemistry. Our solar system sits comfortably within this habitable zone, in what might be considered the galaxy's Goldilocks region. Fact 46. The Milky Way produces cosmic rays, high-energy particles that zip through the galaxy at nearly the speed of light. These particles, mostly protons and atomic nuclei, are accelerated by supernova shock waves and other violent events. Cosmic rays constantly bombard Earth from all directions, passing through your body at this very moment, about 1 particle per square centimeter every second. Most pass through harmlessly, though over evolutionary timescales, cosmic rays have contributed to genetic mutations and the evolution of life. These particles have traveled thousands of light years through the galaxy before reaching you, tiny messengers from distant cataclysms. Fact 47. Our galaxy contains mysterious objects called Thornzico objects, theoretical stars that might have a neutron star at their core instead of a normal stellar core. Imagine a star that has swallowed a neutron star, creating a bizarre hybrid object unlike anything else in the universe. From the outside, it would look like a red supergiant star, but at its heart would be a neutron star, incredibly dense and exotic. Only a few candidate Thornzico objects have been identified so far, and astronomers are still studying them to confirm their nature. If they exist, they represent one of the strangest possible outcomes of stellar evolution. Fact 48. The Milky Way is filled with rogue planets, worlds that don't orbit any star but instead wander through the galaxy alone. These planets were likely ejected from their birth solar systems by gravitational interactions, flung into the darkness to drift forever. Some estimates suggest there could be billions of rogue planets in our galaxy, perhaps even outnumbering the stars themselves. These lonely worlds travel through the cold and dark, their surfaces frozen and lifeless, never feeling the warmth of a sun. Some might still have internal heat, and a few could even have subsurface oceans kept liquid by radioactive decay or tidal heating from large moons, though they would be invisible from the surface under thick ice. Fact 49. The Milky Way's disk is not uniform but contains structures called spiral density waves and spurs. In addition to the 4 major spiral arms, there are numerous smaller features and connecting structures. The Orion spur, where we live, is one such feature. It's not a major arm but a connecting structure between the Perseus and Sagittarius arms. These spurs are regions where material has bunched up, creating local increases in star formation. Our Sun happens to be located in one of these minor features, making our galactic address quite specific. The Orion spur, about 26,000 light-years from the center, in the inner edge of the spur, on the quiet outskirts of a stellar neighborhood. Let your consciousness expand now to encompass these realities. You are on a planet, orbiting a star, in a minor spur of a spiral arm, in a galaxy containing hundreds of billions of stars and perhaps trillions of planets. Cosmic rays from ancient supernovae are passing through you. The light of billions of distant suns combines to paint the Milky Way across your sky. And somewhere out there, rogue planets drift in eternal darkness, and strange hybrid stars burn with neutron star hearts. The universe is vast, but you are part of it, connected to everything through the simple fact of existence. Rest in that connection, and let it carry you gently into sleep. As you float in that peaceful space between waking and dreaming, let's explore the ancient history of our galaxy, the long story of how the Milky Way became what it is today. Fact 50. The Milky Way wasn't always the majestic spiral we see today. In its earliest days, over 13 billion years ago, our galaxy was a chaotic, turbulent cloud of gas with no defined structure. It took hundreds of millions of years for gravity to organize this primordial material into the rotating disk we recognize now. The galaxy grew through a process called hierarchical assembly, where smaller protogalaxies merged together, each collision adding mass and angular momentum, slowly building the structure we inhabit today. In a sense, the Milky Way is a patchwork quilt, stitched together from numerous smaller galaxies over billions of years. Fact 51. Evidence of the Milky Way's violent past is written in its stars. Astronomers have discovered that many of the stars in our galactic halo have unusual orbits. They're moving in directions that don't match the galaxy's overall rotation. These are likely stars that were captured from smaller galaxies that the Milky Way consumed long ago. One such victim was the Gaia Enceladus galaxy, which merged with the Milky Way about 10 billion years ago. This ancient collision dumped billions of stars into our galaxy, and we can still identify them today by their distinctive chemical signatures and orbital patterns. They're cosmic fossils, memories of a merger that happened before our solar system even existed. Fact 52. The Milky Way contains about 150 known globular clusters, ancient balls of stars that orbit the galaxy like satellites. Each globular cluster can contain hundreds of thousands to millions of stars, all packed into a region only a few dozen light-years across. These clusters are among the oldest objects in the galaxy, with some dating back more than 12 billion years. Looking at a globular cluster is like looking back in time to see what the early universe was like. The stars are so densely packed that if you lived on a planet inside a globular cluster, you'd see thousands of bright stars in your sky, turning night into perpetual twilight. Fact 53. The Milky Way has consumed many smaller galaxies over its lifetime, and it continues to do so today. Right now, the Sagittarius dwarf elliptical galaxy is in the process of being torn apart by our galaxy's tidal forces. It's currently passing through the Milky Way's disk, and over the next few 100 million years, it will be completely absorbed, its stars becoming indistinguishable from our own. This is galactic cannibalism, and it's a normal part of how large galaxies grow. The Milky Way has grown fat on smaller galaxies, and each merger adds to its mass and complexity. Fact 54. Our galaxy's disk shows evidence of past collisions in its structure. Astronomers have discovered that the disk isn't perfectly smooth but has vertical waves rippling through it, like ripples on a pond after a stone is thrown in. These waves were likely caused by the passage of a smaller galaxy through the Milky Way's disk millions of years ago. The collision sent shock waves through the disk, setting stars bobbing up and down in vertical oscillations that persist to this day. We're living in a galaxy that's still ringing like a bell from ancient impacts. Fact 55. The metallicity of stars in the Milky Way tells a story of chemical evolution. The very first stars were made of almost pure hydrogen and helium, but each generation of stars has enriched the galaxy with heavier elements. By measuring the chemical composition of stars, astronomers can estimate their ages and trace the history of star formation in different parts of the galaxy. Stars in the halo are typically metal-poor and ancient, while stars in the disk like our Sun are metal-rich and younger. The galaxy has been slowly seasoning itself with heavier elements, and we're the beneficiaries of billions of years of this cosmic cooking. Fact 56. The Milky Way's rotation has a curious property. Different parts of the galaxy rotate at different speeds, but not in the way you might expect. In the inner regions, closer to the galactic center, the galaxy does rotate somewhat like a solid body, with rotation speed increasing with distance. But beyond a certain radius, the rotation speed becomes nearly constant, staying roughly the same all the way out to the edge of the visible disk and beyond. This flat rotation curve was one of the key pieces of evidence for dark matter, because there simply isn't enough visible matter to account for the speeds we observe. Something invisible must be there, holding the galaxy together. Fact 57. The Milky Way has experienced periods of intense star formation called starbursts. During these episodes, which likely occurred after major galaxy mergers, stars formed at rates hundreds or thousands of times faster than the current rate. Gas compressed by the collision would collapse rapidly, igniting vast numbers of massive stars in a relatively short time. These starburst periods would have lit up the galaxy with brilliant blue light and filled it with supernova explosions. Between starbursts, during quieter periods like now, star formation proceeds at a more sedate pace. Our galaxy breathes, alternating between frenzies of creation and long periods of calm. As you rest deeper now, imagine the vast timeline of our galaxy. 13 billion years of collisions and mergers, of stars being born and dying, of chemical elements being forged and scattered. The Milky Way you see in the night sky is the latest chapter in an epic that began when the universe was young. And you, resting peacefully on this small world, are made from the products of that long story, atoms forged in ancient stars, assembled into molecules, organized into cells, aware and contemplating the galaxy that created you. The story continues, slow and patient, on timescales that dwarf human history. Rest now, and be part of that eternal story. As you settle into the deepest layers of relaxation, let's discover some of the most beautiful and intriguing objects that adorn our galaxy, the jewels scattered throughout the Milky Way's spiral arms. Fact 58. The Milky Way contains vast nebulae, clouds of gas and dust that glow with ethereal colors. The famous Carina Nebula, located about 7,500 light-years away, spans over 300 light-years across and is one of the largest and brightest nebulae in our sky. Within its billowing clouds, stars are being born at a prodigious rate. The nebula glows with reds from hydrogen, blues from oxygen, and other hues from various elements, all illuminated by the ultraviolet light of young, hot stars. These cosmic tapestries are among the most photographed objects in astronomy, and their beauty reminds us that the universe is not just vast and dark, but also filled with color and light. Fact 59. Red giant stars populate our galaxy in enormous numbers. These are stars that have exhausted the hydrogen fuel in their cores and expanded to hundreds of times their original size. Betelgeuse, the bright red star in the constellation Orion, is one of the most famous red giants. If placed at the center of our solar system, Betelgeuse would extend past the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars in its outer atmosphere. Our own Sun will become a red giant in about 5 billion years, swelling up to perhaps the orbit of Earth or beyond. But don't worry, that's so far in the future that the thought should be more fascinating than frightening, a distant chapter in the Sun's long story. Fact 60. The Milky Way has a feature called the galactic bar, a dense concentration of stars extending from the central bulge. This bar is about 27,000 light-years long and rotates as a rigid structure, faster than the spiral arms around it. The bar plays a crucial role in the galaxy's evolution by funneling gas from the outer disk toward the center, feeding star formation in the inner regions. About 2/3 of spiral galaxies, including ours, have these bars. The bar wasn't discovered until the 1990s because we're viewing it nearly end-on from our position, making it difficult to detect. We're living inside the structure we're trying to study, like trying to understand the shape of a forest while standing among the trees. Fact 61. Throughout the Milky Way, there are stellar associations, loose groups of young stars that were born together but aren't gravitationally bound like globular clusters. These associations gradually drift apart over time as the stars go their separate ways. The Pleiades, also known as the Seven Sisters, is one such stellar association, a cluster of young blue stars about 440 light-years away. You can see them with the naked eye as a small, fuzzy group of stars. The Pleiades stars are only about 100 million years old, youngsters compared to our 4.6 billion-year-old Sun. They're still surrounded by wisps of the gas cloud from which they formed, creating a faint blue reflection nebula. Fact 62. The Milky Way contains thousands of planetary nebulae, though despite their name, they have nothing to do with planets. These are the beautiful, expanding shells of gas ejected by dying stars like our Sun. When a Sun-like star exhausts its fuel, it puffs off its outer layers in one or more shells, which are then illuminated by the hot, exposed core of the star. The result is a glowing bubble or ring of gas, often with intricate structures shaped by magnetic fields and binary companions. The Ring Nebula and the Helix Nebula are two famous examples. These nebulae last only about 10,000 years before dispersing into space, making them fleeting monuments to stellar death, cosmic tombstones that glow with quiet beauty. Fact 63. Our galaxy harbors white dwarf stars by the billions. These are the final evolutionary stage of stars like our Sun, dense, Earth-sized remnants composed mostly of carbon and oxygen. A white dwarf is so dense that a teaspoon of its material would weigh about 5 tons on Earth. White dwarfs glow from residual heat, slowly cooling over trillions of years. Eventually, they'll fade to become black dwarfs, cold and dark cinders drifting through space. However, the universe isn't old enough yet for any black dwarfs to exist. Even the oldest white dwarfs are still faintly warm. They're like cooling embers from fires that burned billions of years ago, still radiating the memory of their former glory. Fact 64. The Milky Way has a phenomenon called gravitational lensing, where the gravity of massive objects bends and magnifies the light from more distant objects behind them. While this effect is more commonly discussed with distant galaxies, it occurs within our galaxy too. Massive objects in the Milky Way, including black holes, neutron stars, and even brown dwarfs, can act as gravitational lenses. Astronomers use microlensing events, brief brightenings of distant stars when a massive object passes in front of them, to detect dark objects that emit no light of their own. It's a way of seeing the invisible, using Einstein's general relativity as a cosmic magnifying glass. Fact 65. The interstellar medium isn't just empty space with a bit of gas and dust, it's a complex, multi-phase environment. There's cold molecular gas where stars form, warm neutral hydrogen, warm ionized gas around young stars, and hot ionized gas heated by supernova explosions to millions of degrees. These different phases coexist and interact, creating a dynamic, ever-changing environment. Supernova shock waves plow through the cooler gas, compressing it and triggering new star formation. Hot gas rises above the galactic disk in galactic fountains, cools, and falls back down. The interstellar medium is like the atmosphere of the galaxy, constantly circulating and renewing itself. Let your mind drift now through this gallery of wonders. Glowing nebulae painting space with color, red giants swelling to enormous size, white dwarfs cooling slowly over eons, and the invisible dance of gravitational lensing. Each object is real, each phenomenon verified by observation. The universe is more beautiful and strange than any dream, and you're resting peacefully within it, cradled by the same gravity that bends starlight and holds galaxies together. Sleep now, surrounded by cosmic beauty, part of the same grand tapestry that includes nebulae and neutron stars, red giants and white dwarfs. As your breathing becomes slower and more rhythmic, let's explore the motion and destiny of our galaxy, the grand journey through space and time that carries us all. Fact 66. The Milky Way isn't stationary in space, it's moving through the universe at tremendous speed. Our entire galaxy is traveling at about 1.3 million miles per hour relative to the cosmic microwave background radiation, the afterglow of the Big Bang. This motion is caused by the gravitational pull of enormous structures in the universe, including the Virgo supercluster and an even larger structure called the Great Attractor. We're being pulled along by invisible tides of gravity that operate on scales almost too vast to comprehend, flowing through space like a leaf on a cosmic river. Fact 67. The Milky Way is part of an even larger structure called the Laniakea supercluster, a galactic supercluster containing about 100,000 galaxies spread across 520 million light-years. The name Laniakea means immense heaven in Hawaiian, a fitting name for this cosmic continent to which we belong. All the galaxies in Laniakea are moving together, drawn by their mutual gravitational attraction toward a central point. Our local group of galaxies, including the Milky Way and Andromeda, is just one small neighborhood in this vast supercluster, like a single house on a street in an enormous city. Fact 68. The collision between the Milky Way and Andromeda, which we mentioned earlier, will be a spectacular event when viewed across cosmic timescales. Computer simulations show that the two galaxies will first pass through each other, their stars interpenetrating like two clouds of gnats. Then gravity will pull them back together for a second pass, and then a third. Over the course of about 2 billion years after first contact, the two spirals will merge into a single elliptical galaxy. Astronomers have even given this future galaxy a name, Milkomeda, a blend of Milky Way and Andromeda. By that time, if any civilizations still exist on planets in either galaxy, they'll witness a sky filled with stellar chaos and beauty. Fact 69. The Milky Way has satellite galaxies orbiting it, just as planets orbit the Sun. We've already mentioned the Large and Small Magellanic Clouds, but there are many more, at least 59 known satellite galaxies at last count, most of them dwarf galaxies containing only a few million to a few billion stars. These tiny galaxies are gravitationally bound to the Milky Way, orbiting it over hundreds of millions or billions of years. The smallest satellite galaxies are so faint that they were only discovered in the 21st century, tiny wisps of stars barely held together by their own gravity and the dark matter that surrounds them. Fact 70. Within our galaxy, stars have different orbital paths based on their location and age. Stars in the thin disk, like our Sun, follow nearly circular orbits around the galactic center, all moving in roughly the same direction like cars on a racetrack. But stars in the thick disk and halo have more eccentric orbits, plunging up and down through the galactic plane and sometimes even orbiting in the opposite direction to the overall rotation. Our Sun's orbit is remarkably circular and stable, bobbing gently up and down through the galactic plane every 30 million years or so, crossing from one side to the other in a gentle oscillation. Fact 71. The Milky Way's future will be profoundly shaped by dark energy, the mysterious force that's accelerating the expansion of the universe. While galaxies within the local group will merge together, driven by their mutual gravity, more distant galaxies will recede from us ever faster. In the far future, trillions of years from now, the night sky from Milkomeda will be nearly empty, with only the galaxies that merged together visible. All other galaxies will have been carried away beyond our cosmic horizon by the expansion of space. Future astronomers in that distant epoch won't see the universe as we do, they'll be islanded in what appears to be an empty cosmos. Fact 72. The Milky Way rotates differentially, meaning different parts rotate at different speeds. This differential rotation creates shear in the galactic disk, and this shear is thought to help maintain and regenerate the galaxy's magnetic field through a process called the dynamo effect. The galactic magnetic field is weak by everyday standards, about 1,000,000 times weaker than Earth's magnetic field, but it stretches across the entire galaxy, threading through the space between stars. This magnetic field helps shape the structure of the interstellar medium, confines cosmic rays, and influences how gas clouds collapse to form stars. It's an invisible web connecting every part of the galaxy. Fact 73. The Milky Way will eventually run out of gas to form new stars. Star formation requires cold molecular gas, and the galaxy is slowly depleting its supply. Some gas is locked up in stars and their remnants, some is heated by supernovae and blown out of the galaxy in winds, and the infall of fresh gas from outside has largely ceased. Unless the galaxy acquires new gas through future mergers, star formation will gradually decline. In about 100 billion years, the galaxy will have exhausted its fuel, and no new stars will be born. The Milky Way will slowly fade as its stars age and die, eventually becoming a dim collection of white dwarfs, neutron stars, and black holes orbiting in the dark. As you rest now, almost completely relaxed, imagine the long arc of the galaxy's life. From its chaotic birth 13 billion years ago, through its current prime as a vigorous spiral, to its eventual merger with Andromeda, and finally to a distant future of slow decline. We exist in a special moment in cosmic history, in an era when galaxies are still forming stars, when the universe is filled with light and activity. You're fortunate to be here now, in this epoch, on this world, conscious and aware. The galaxy's story is vast, but your moment within it is precious. Rest in that knowledge, and let the cosmic currents carry you gently into dreams. As you float in that peaceful space on the edge of sleep, let's complete our journey through the Milky Way with some of the most profound and awe-inspiring facts about our cosmic home. Fact 74. The Milky Way contains organic molecules floating in space, the building blocks of life scattered throughout the galaxy. Astronomers have detected over 200 different molecules in interstellar space, including water, ammonia, formaldehyde, and even more complex organic compounds like amino acids and sugars. Some of these molecules exist in vast clouds, while others coat the surfaces of dust grains. These cosmic chemistry sets suggest that the ingredients for life are common throughout the galaxy, perhaps even inevitable given the right conditions. The universe seems to be preparing recipes for life in countless locations. Fact 75. The light from the center of our galaxy takes about 26,000 years to reach us. This means when you look toward the galactic center, you're seeing it as it was 26,000 years ago, long before recorded human history began. The light that's reaching your eyes right now began its journey when woolly mammoths still roamed the earth and our ancestors were painting caves in Europe. In the same way, light from our sun takes about 8 minutes to reach us, and light from the nearest star takes over 4 years. The universe doesn't just show us space, it shows us time, allowing us to peer into the past simply by looking at distant objects. Fact 76. The Milky Way has a synchronization pattern in how its stars orbit. Despite the differential rotation we mentioned, there's a surprising degree of coherence in how structures move through the galaxy. Stars born together in clusters tend to move together for a while, and even after millions of years, some patterns persist. The spiral arms themselves are thought to be density waves that maintain their shape even as individual stars pass through them. It's as if the galaxy has a memory, encoded in the positions and velocities of billions of stars, a memory that persists across hundreds of millions of years. Fact 77. The oldest star found in the Milky Way so far is estimated to be about 13.5 billion years old, almost as old as the universe itself. This ancient star, with the catalog number HD 140283 and nicknamed the Methuselah star, contains very few heavy elements, confirming it formed when the universe was still mostly hydrogen and helium. This star has witnessed almost the entire history of our galaxy. It was already ancient when our solar system formed, already billions of years old when the first life appeared on Earth. Looking at this star is like meeting someone who was present at the galaxy's creation, a living fossil from the cosmic dawn. Fact 78. The Milky Way influences the evolution of life on Earth in ways you might not expect. As our solar system orbits the galaxy, it passes through the spiral arms every few 100 million years. Some scientists have proposed that these passages might correlate with mass extinctions on Earth, because the increased density of stars and gas in the spiral arms could disturb the Oort cloud at the edge of our solar system, sending comets toward the inner solar system. While this hypothesis is still debated, it suggests that events on a galactic scale might have shaped the history of life on our small planet, that the galaxy's structure has reached down across thousands of light-years to influence evolution itself. Fact 79. The Milky Way is part of the cosmic web, the largest structure in the universe. If you could zoom out far enough, you'd see that galaxies aren't randomly distributed but form a vast network of filaments and walls surrounding enormous voids. The Milky Way sits on one of these cosmic filaments, connected through dark matter and gravity to countless other galaxies across hundreds of millions of light-years. These filaments trace the original distribution of matter from the early universe, patterns that were set in motion just moments after the Big Bang and have been slowly evolving ever since. Fact 80. Within our galaxy, there are X-ray binaries, systems where a normal star orbits a neutron star or black hole, and material from the normal star is pulled onto its compact companion. As this stolen gas spirals inward, it heats up to millions of degrees and emits intense X-rays. These systems are some of the brightest X-ray sources in the galaxy, visible across thousands of light-years. They represent an exotic phase of stellar evolution, where the dead remnant of one star feeds on its living companion, creating a cosmic vampire that illuminates the galaxy with high-energy radiation. Fact 81. The Milky Way's total mass is estimated to be about 1.5 trillion times the mass of our Sun, though this estimate includes all the dark matter in the galactic halo. The visible matter, stars, gas, dust, everything we can see, makes up only about 10% of this total. The rest is dark matter, that mysterious substance that interacts with normal matter only through gravity. Despite all the stars and nebulae, all the black holes and neutron stars, the vast majority of the galaxy's mass is invisible and unknown. We live in a galaxy dominated by mystery, where most of what exists remains beyond our understanding. Fact 82. Every atom in your body came from the Milky Way. The hydrogen formed in the Big Bang, but everything else, the carbon in your DNA, the calcium in your bones, the iron in your blood, was forged inside stars that exploded billions of years ago. These atoms drifted through space, mixed with gas clouds, collapsed to form our solar system, coalesced into Earth, and eventually became part of you. You are not separate from the galaxy, you are the galaxy experiencing itself. You are stardust that has organized itself to contemplate the stars. In the most literal sense, you are the Milky Way looking at itself. Fact 83. And finally, as you drift into sleep, consider this: the Milky Way is your home in the deepest sense. Not just Earth, not just the solar system, but this entire galaxy of hundreds of billions of stars. Every photon of light that has ever reached your eyes came from the Milky Way or from even more distant regions beyond. Every atom you've ever touched, Every breath you've taken, every person you've loved, all of it has been within this galaxy, part of this cosmic island in space. You are a citizen of the Milky Way, living on a beautiful world, in a beautiful solar system, in a spectacular galaxy that has been spinning through the universe for 13 billion years. Rest now, child of the stars. Let the weight of these wonders press gently on your mind like a soft blanket. You are home, you are safe, you are part of something vast and ancient and beautiful. The galaxy turns, the stars shine, and you are exactly where you belong. Sleep peacefully, knowing that you are made of starlight, cradled by gravity, and connected to everything that exists. The Milky Way holds you in its spiral arms. Good night.